Hey everybody. So again, asked to do a problem. I'm gonna. There's a group of them. And it's 42 to 46, and I'm gonna do 42, and then I'm gonna explain how to do 45. 43 and 44 will act like 42, and then 46 will act like 45. So first of all, the problem you have for 42 is you're given this expression. We're supposed to evaluate it 1 plus I to the k power when k is 4, 8, 12, so on and so forth. And we're supposed to predict it, what's going to happen when it's at 16. Whenever you're dealing with a problem like this, you're looking for a pattern to be established. And patterns tend to lead themselves right away. Like you'll notice this is a distance of 4, a distance of 4, a distance of 4. So we're looking for things that have a distance apart of 4 or a group of 4. So I'm going to start off with k is 4. So that's 1 plus I to the 4th, or 1 plus I times 1 plus I times 1 plus I times 1 plus I. Well, I'm going to break this up into two groups. So I'm going to multiply these two, and I'm going to multiply these two, because the multiplicative property is commutative, or associative as well. So I can change the order and multiply, or I can decide to multiply out of order if I have a string of multiplications. So 1 times 1 gives me my 1, 1 times I is 1I times 1 is 2I, because I add them together. I times I is I squared. Now recall that I squared is negative 1, so this is really 1 plus 2I minus 1. And I get the same thing here, 1 plus 2I minus 1. Well, when you add those, or you clean those up, so to speak, you get 2I times 2I, which is 4I squared. Well, I squared is negative 1, so this becomes negative 4. So for a group of 4 of them, we get a negative 4. So I wrote out 8. There's 4 of them, there's 4 of them. This group will give me negative 4. This group will give me negative 4, so that gives me a positive 16. So now if I have a group of 12, I have 3 groups of 4, and I have another group over there. So that's negative 4 times negative 4 times negative 4, and I get negative 64. For 16, that's 4 groups, and so I end up with 4 groups of 4, which is 16 times 16, or 256. All right, now you're going to look for those kind of patterns when you're dealing with 45 or 43 and 44. For 45, they ask this question: is this a solution to this equation? And what does it mean to be a solution? It means you plug this value in and you get a true statement. So I'm really looking at this expression plugged into the x, so I see it written 6 times. I put dot, dot, dot because I ran out of space. So there's 6 of them. And so I just want to show you how to multiply 2 of them together, because you can go 2 of them together, 2 of them together, 2 of them together, and then you can multiply 2 of them, and then, so on. And you're just looking for a true result. You're just trying to get the value to equal 0. So square root of 3 over 2 times the square root of 3 over 2 is 3 over 4. Square root of 3 over 2 times 1/2 I is square root of 3I over 4. And we get the same there. So there's 2 of them. So we have 2 square roots of 3 over 4, and there is supposed to be an I there. Well, my 2's will reduce, and I'll get square root of 3I over 2. Now remember, I squared is negative 1, so this is negative 1/4. So I have negative 1/4 plus 3/4, which is 2/4, or it is my 1/2. So I have 1/2 plus the square root of 3I over 2, and that's for each pair. Now, when you work it through, you'll end up getting down to a negative 1 plus 1 is equal to 0. And then you have a true statement, which shows, that's a T by the way, which shows that that is a solution. Okay, hopefully that's helpful.